as we have studied earlier, that a force can change a state of motion. When we talk about the state of motion, it is velocity vector. And change in velocity is caused by acceleration. So we can simply state whenever a force is applied, force causes acceleration. And acceleration implies change in velocity. As we have studied earlier also, that a velocity is represented by two parameters. One is its magnitude and other is its direction. In both the cases, whether magnitude changes or acceleration causes change in direction, in both cases we say the state of motion of body is changing. Say for example, if there is a body of mass m moving with a velocity vector v, so it is moving in a straight line. In this process, if we apply an external force F onto it, due to the force, this velocity magnitude will increase. As force is applied in the direction of velocity, so it will cause the body to speed up. So in this situation, we can say the magnitude of velocity is increasing. However, the direction in this situation is not going to change because force is applied in the direction of velocity, so it will only increase the speed, or it will increase the magnitude of velocity. But if we consider another case in which, say, again we are having a body of mass m, it is moving with a velocity vector v. If we apply a force which is perpendicular to the motion of velocity, force is also a vector quantity. If we consider the direction of force which is perpendicular to velocity, you can see it is not going to change the speed. Due to this force, the body direction is going to change. It will bend in the direction of force. It depends on how large the mass of body is, which is going to decide how fast the body will take a turn. If it is a very lightweight body, very soon it will take a turn. If it is very heavy, because of inertia, it will gradually take a turn in a large radius of curvature. So you can simply state, in this situation when force is applied in a perpendicular direction to the motion, you can say direction of velocity vector is changing. So there are two effects which a force can cause in a state of motion of a body. That is a parallel force causes change in magnitude of velocity, and a normal force which is applied perpendicular to the direction of motion, it causes change in direction of velocity vector. So always keep in mind that a force can change the state of motion in two ways. If force is acting in the direction of velocity, it will change the magnitude of velocity. If force is applied in the direction normal to velocity, that is at right angle to the direction of motion, then it will not change the magnitude, it will only change the direction of velocity. To understand the concept in a better way, we just take up a practical illustration. Say we are having a coordinate system xy. In this coordinate system, a particle starts from point A and say it moves along with this path and goes to the point B. In this situation, if we consider any point where body is moving, the particle is moving with a velocity vector v. So we can say as the particle is moving in a curve, its direction is changing. It may be possible that its magnitude is also changing. And at this point, it is quite sure that velocity direction is along the tangent of the curve in which it is moving. That is the trajectory of its motion. So at this point, a force F is applied to this particle at an angle theta to the direction of its motion. That is angle from the tangent of this particle at this point of the curve. Now, if we talk about the force, this force will have two components. One is along the tangent and this component will be F cos theta. Other component of this force will be along the normal to the curve, that is trajectory of motion, that is F sin theta. So here you can say a component of force F cos theta is acting along the direction of velocity and F sin theta is acting perpendicular to the direction of velocity. So in this situation we can write the force F cos theta which is acting along the direction of velocity is responsible for change in magnitude of velocity vector, and F sin theta, the force which is acting perpendicular to velocity, is responsible for change in direction of v vector. This is the way how we analyze the things. Whenever a particle moves, a force acts on it, we can directly state the component of force which is acting along velocity will change the magnitude of velocity, the component of force which is acting perpendicular or normal to velocity vector, it will change the direction of velocity.